Hello, everybody. I'm Everton de Oliveira from the Groundwater Project, and I'm very pleased to bring to you a very new book, very interesting. I was talking to the authors here, and just like I thought that I knew something about infiltration rates and things, and it's good to get a book and be surprised that you can learn. Even old people can learn something, as they say, right here. It's never too late. It's a very good book, The Quantification of Groundwater Recharge. So I do recommend that. The authors are Peter Cook and Philip Brunner. They're here. Welcome, guys. Congratulations for your great book. I'll be very brief in here. Peter Cook is a professional research fellow at Flinders University in South Australia, and a director of the Australian National Centre for Groundwater Research and Training. Welcome, Peter. And Philip Brunner is, since 2012, is a professor for hydrogeology at the University of Neuchâtel in Switzerland. Welcome, both of you. I just made a brief introduction of both of you. I know both have a very long curriculum. People are really are invited to download the book. It's free. It's very good, and you can check the nice curriculum that they have. Welcome, guys. Please tell us a little bit about yourselves and how and why you teamed up to create the book Quantification of Groundwater Research. Welcome. Thank you.
Thanks, Everton. Well, I've been working on issues related to groundwater recharge since I first began working as a hydrogeologist many years ago. And originally that was looking at dryland salinity problems in southern Australia. And in that environment, the rate of groundwater recharge actually controls the rate at which salinisation processes develop. So that was when I started. I've continued to work on recharge since that time, really, not so much in salinity, but it's always been an area that's been relevant to the projects that I've been doing, whatever they are. It's a critical component of any aquifer water balance.
Very good. Philip.
Yes, well, perhaps I can just add, I did my master thesis in Botswana, and the focus was on groundwater recharge. And what we tried to do there was to combine satellite images with the chloride method. And I wrote that up as a paper, and I sent it out. And coincidentally, Peter Cook was the reviewer. So that was the first time we got in touch with groundwater recharge. That's a long time ago already. And then for me, I kept on doing my PhD, and I was in China. And of course, groundwater recharge was also a very, very critical question there. And after my thesis, I went to Peter, to Flinders University to do a postdoc. And there we worked on different topics too, but groundwater recharge was always a common denominator between us. And I think this is what finally also led to this book here.
Oh, that's very nice. That's very nice. So I have a question for you. Groundwater science has historically been focused on groundwater extraction, right? Like we were chatting here before, when we're modeling, we just throw some numbers for infiltration and try to match the model, right? But I have a sense that infiltration for groundwater control and all over the world is going to be a big thing in the future. Could you explain the importance of accurately quantifying groundwater recharge?
Yeah, it's a really good question. And initially, we probably were focused on quantifying groundwater recharge because we wanted to assess whether groundwater extraction was sustainable. And the belief at that stage was, well, if we're taking out less water than is going in, then groundwater is sustainable. We know now that it's much more complicated than that. The environment is a very important water user, and just because we're using less than the recharge doesn't mean that the rivers won't dry up, the trees won't die, the lakes won't dry up, etc. So it's much more complicated. But still, I mean, groundwater recharge is an important part of most water resource problems, regional water resource, groundwater aquifer storage questions. I would think one of the really critical roles for quantifying recharge today is for calibrating our groundwater models as accurately as possible. We know we can't estimate hydraulic conductivity with any sort of accuracy. So relying on that for model calibration is questionable, and recharge is really important for that.
Good. You have some examples for that, Peter, for why is that important, or when we're using that, so people can anticipate or see better. So an example?
Philip, does something come to mind there?
Well, yes. I mean, perhaps before you bring some examples, Peter, it's also an important aspect is also to know how groundwater recharge will change in the future. And there can be many drivers for that. It could be a land use change, climate change, thawing permafrost. And given that groundwater in many countries is such an important water resource, in Switzerland, about 80% of the drinking water are produced from aquifers. So it's really, really important to also to anticipate certain changes which could occur to the groundwater body. And one of the big ones is, of course, groundwater recharge.
True. That's true. Very important. I talked to some people in Argentina, some vineyards there. They're recharged by, also, snow melt, and things that they're really concerned about that in the near future. Interesting. Okay, so for people that don't know, what's the difference between infiltration, drainage, and recharge? That's the name of one of the chapters of your book.
You want to start, Peter?
Yeah, well, that's actually a more difficult question than it should be, and it's Philip and I have thought about this over the last few years. It's very hard to really accurately define some of these fluxes, but in simple terms, so the infiltration rate is the amount of water, the rate that water moves below the soil surface. Okay, rainfall, some of it runs off, some of it moves into the soil. So that's infiltration, how much moves into the soil. But a lot of the water that moves into the soil will then get extracted by the plants and used for transpiration. So we use the term drainage to talk about that amount of water that gets below the plant roots and that moves more deeply through the soil. Eventually, most of that drainage that moves below the plant roots will reach the water table and replenish the aquifer. And that's what we refer to as groundwater recharge. So sometimes we use the words a bit loosely and interchangeably, but strictly speaking, it's recharge when it gets into the aquifer. Drainage is on its way there, but not there yet. And infiltration is a much, much larger number. Infiltration is how much enters the soil. Most of that comes straight back out.
It's actually funny you ask this question. I was just correcting my exams today, and one of the questions I asked is why, or mention reasons why infiltration is higher or larger than groundwater recharge. So infiltration is reduced by these processes that Peter mentioned, for example, uptake through vegetation. It could also be that some of the water will evaporate, not through plant roots, but really be evaporated from the soil. That's another reason why infiltration is essentially always larger than groundwater recharge. And another big difference is there can be a significant delay between infiltration, then the drainage process, and subsequent groundwater recharge. Infiltration happens after irrigation or a rainfall event, but till this turns into groundwater recharge can take a very long time, and is, for example, dependent on the soil type or the extent of the unsaturated zone as well.
That's a very important point, right? When people, most people that I know in the field, they just measure the infiltration rate, right? And they use that as recharge directly. That's what really happens, right? And it's far from the truth, right? So that's quite.
Yeah. And the drier the country you're in, the further it is from being correct.
Yes, true, true. So,
And one thing to add, perhaps just on that, I mean, many people also use precipitation and not infiltration. And for example, in forested
true.
catchment, interceptions can be up to 30%. So infiltration is actually not that easy if you want to measure. The first approximation is, of course, the rainfall, if you know that well enough. But interception can play an important role in forested catchments, for example, or in areas where the soil is compacted and there is a lot of surface runoff generated.
Yeah, true, true. Good. So, one point I asked you in a different way, but does the extensive agriculture promote groundwater recharge, or does it depend on specific conditions, and why?
So recharge is usually more under agricultural crops than it is prior to clearing. So under native vegetation, trees are usually deeper rooted than agricultural crops. They're more water efficient, meaning they can dry the soil out to a much greater extent than agricultural crops essentially fall over when the soil gets, a little bit dry, whereas native vegetation is, particularly in arid areas, is adapted to keep going. So we clear the native vegetation, we put on shallow rooted crops that can't extract water from the soil as well. And yes, recharge usually increases.
Mm.
More water is not always a good thing though. In many areas of the world, increased recharge due to agriculture has led to salinity developing, salinity in groundwater, then rising water tables, saline soils. So, more groundwater recharge shouldn't be equated as a good thing. It depends entirely on the environment. But yes, I mean, recharge is usually greater under agricultural crops, and even more so if they're irrigated.
Can I add one small thing? There are areas where the irrigation water is essentially pumped by groundwater. So if irrigated irrigation takes place, it's really important if you want to know how the water table reacts, where the water comes from. Is it diverted from a river and brought in there? Or is it groundwater pumped and then used on large pivots? So it can be context specific. You can also see the opposite, even though, Peter mentioned the common cases already.
No, I had in mind one case in India. They have this regenerative agriculture in a huge land surface of the country there, and they always say, you see people, of course they're not specialists, saying that the vegetation increase the recharge a lot. They talk about 250,000 wells that were dry and now have water. But what actually happens is that they put lots of trenches to catch water. So whatever was dry before, right, gets water first, and then the vegetation develops. So it's more related to that than to vegetation in itself, right? Maybe the vegetation might soften the soil a bit and increase permeability. That's another possibility.
Yeah, and it depends what was there before the vegetation, before the agricultural crops, and how how the water use of those different, different vegetation types differs.
Yeah, yeah, interesting. Okay, so I have a point here, because you have so many aquifers that are drying up, like the Ogallala aquifer in US and many other places in the world are, over exploiting water, groundwater, in many places. So there is a growing need to store water. Many people are studying how to do that. How does your book help shape our understanding and guide better recharge practices?
You want to start, Peter?
Sure. So, clearly groundwater use is increasing globally, and as surface water resources become fully exploited and fully allocated, the only option for extracting more water is groundwater. So there's more pressure on groundwater. I would say that increases the need for us to manage groundwater sustainably. It's not necessarily about increasing the storage of the aquifers or the ability to store water in aquifers. It's managing how much we're extracting, making sure we're not over extracting. It really, the way forward is to manage all aspects of the groundwater system better. And it's, with all of these things, it's tempting to look at one part of the puzzle and to say how we should treat that, but it's understanding the big picture and understanding what the recharge is, understanding what the extraction is by us, understanding what the natural discharge might be. Where was the groundwater going naturally? Have we changed those pathways? It's really trying to understand the whole groundwater system.
Sure. Really.
Yeah, I agree. And I mean, when one manages groundwater, one should not forget groundwater is just a part of the hydrologic cycle. It is not an isolated entity. It interacts with rivers, it reacts to land use changes, etc. So, as Peter said, the focus should really be to manage the water resources as a whole in a sustainable way. And managed groundwater recharge can be an instrument there. So can be for example, artificial infiltration along rivers or a targeted extraction. These are all certain instruments which allow to manage groundwater together with the other components of the hydrological cycle.
Okay, so how does your book help then understanding and practicing this better groundwater management?
Well, I mean, sorry, Peter, just go for it.
You can go first if you want, Philip.
So, I mean, one challenge with groundwater recharge is really to put numbers to it. And the book has many examples and approaches on how to quantify groundwater recharge. And all of these methods, they have different spatial and temporal scales. Some of them are suited for humid areas, others are suited more for arid areas. So I think the book helps a little bit in providing instruments that can be used to quantify groundwater recharge. And of course, there is also an explanation of the relevant processes. For example, this delay between infiltration and recharge is important when one manages water resources.
Yeah, and diffuse and focused recharge as well. So it is well structured for putting our ideas in place when you read your book. I really enjoyed that. I knew that, I know, conceptually, but now I have a very clear picture after the book. That's very helpful.
Yeah. Absolutely, and you need to understand what the dominant recharge processes are at any particular site in order to determine how best to quantify it. If it's diffuse recharge, if it's focused recharge, is it recharge through irrigation? If we don't understand the processes, we can't develop or use the best approaches for quantifying it. The other thing that we've focused on in terms of quantifying recharge is methods that work well at larger scales. There are a number of methods that have been used for quantifying recharge, things like lysimeters, traditionally from agricultural science.
Yep.
Really nice tools for understanding processes. Don't help someone manage an aquifer because they're really, really small scale. So we've sort of biased our book, if you like, on what are the methods that work well at the large scales.
Yes, I agree. Interesting. So what are the main methods for quantifying groundwater recharge and how are they presented in your book?
I'd have to look at the book first to remind myself. What have we?
While you flick through, Perhaps I will just mention a point that Peter just said before. It really depends on the relevant processes. For
Yes,
example,
yes.
in
Well,
an arid
I
region,
can help you. Start with with the large scale when we need to go for the large scale. So what do you have on that? Because those are people when they think about infiltration rates, they only think on small scale, just like the lysimeters you mentioned or something like that, and don't see the big picture, which is very important.
So one of the tools that we talk about a little bit in our book for estimating, for quantifying recharge, is the groundwater chemistry.
Yeah.
And that's probably not the first thing that people would think about when they want to quantify recharge. But it's really useful at large scales because the chemical signature of the water carries with it a history of its flow path. Okay, so if we measure the water chemistry at a point, it's not telling us about what's happening at that point. It's telling us what's happening over that whole flow path before the water got there. So chemistry proves to be a really useful way for getting large-scale information on recharge and other processes. Whereas, in contrast, if you do a pumping test at a bore, that's telling you about the hydraulic conductivity right at that point or for a very small area around that. And so this is a difference with the chemistry and with some of the hydraulic approaches. And so some of the good methods for looking at regional scale groundwater recharge are chemical approaches.
I mean, what has also been used quite a bit are large-scale water balance approaches. There one just has to say that in arid or in semi-arid areas, these approaches are quite difficult because you can have very targeted recharge for a short, intense time, and it is then in these days or weeks where recharge happens and not throughout the year. So in humid areas, large-scale water balances, I would say, have been used with a certain amount of success. In arid areas, it's a little bit more complicated. You cannot compare average values, but still it can provide some information on an upwind, for example. Huh? Mm.
Interesting. And for more local scale.
To measure recharge, to
Like
estimate
yes,
recharge.
like the focus, for example, focus recharge that is mentioned in the book.
Yeah, so I mean, if you are, for example, interested on groundwater recharge along a river, uh, there are a whole bunch of considerations. The first one is, well, does the river actually infiltrate
Yes.
or drain the aquifer? You can establish that very, very easily with two piezometers, huh?
Yes.
And then, of course, there is a lot to be learned from the chemistry of the groundwater too, if it's under a focused infiltration from a river. And you can also use hydraulic methods, even though they are challenging. There are quite some uncertainties, but the water table variation under a river in response to the river's transients can tell you quite a bit about groundwater recharge as well. Mm.
Good. All right. Thank you. So I could keep asking you questions about recharge for so long, but then people wouldn't read the book. They have to read the book to learn well. The book is so good, and it's well and it's very easy to read. Very easy to read. So congrats for your work. Who is your target audience? Is it for a general hydrogeologist or for a specialist? What do you think?
I always find that a really tough question, Everton.
I do,
And I think
I
it's
do too, but
I think it's varied. But one of the things that's really difficult in science, when you come into a new area, whether you're starting out as a student or even if you're sort of change areas a little bit and you've been working for a while, when you come into a new area, it's very, very hard to get a good feeling for the topic, to come to grips with it. Because, you read the papers in the literature, and most of the papers in the literature assume you've read all the papers that preceded it. Okay, so So to start out can be really hard. So what we've tried to do is give a broad coverage. So we would hope it's useful for students. We would hope it's useful for hydrogeologists, people that have worked in hydrogeology for a long time, but maybe not focused on groundwater recharge and recharge processes and quantifying recharge.
That's me.
So we've written it for as broad an audience as we could. And we would hope that anyone that reads it would get something out of it.
Good. No, my feeling from reading the book, I think anyone should read the book. It's very readable, and it's a very informative and gives you good idea on how to see groundwater in general. We think we can do groundwater management, and then you see that you need more information than you actually had, right? So I do recommend the book for anyone, even the students starting, because the concepts are very I don't know, at a level of a student they can learn. It's not too difficult, but they are very, very well presented, the structure and everything. So congratulations for your work, guys. Okay. So please,
Well,
have any final consideration, any thought that you could add, please? Welcome.
Not from me. I think that's good. I think
it's very nice that this can be presented through the Groundwater Project, I have to say. So it's a free book, everyone can read it, and I think it was nice to contribute to the Groundwater Project. So,
Thank you very much, guys, and congratulations again for your book. I really enjoyed reading your book. Some books are, when it's very specific, it's much harder to see. But this is this is a specific, but it's different. I really like. I don't know how to put that in words, but I really enjoyed it. Congrats, Peter and Philip, for a nice work. So I'm looking forward for another book from you, Peter and Philip. Please do it. You're good.
I'm not sure it's going to happen in the hurry of it.
I know it's a tough call, but
it's a long process. I don't remember when we started this one. It's a long process, but it's a good one, and I enjoy doing it. Yeah.
Yes, me too.
Good. And readers will enjoy that for sure. Thank you very much, guys. Congratulations.
All right. Thanks, everyone.
Thank you.
All right.
Bye.
Bye-bye. Bye.